Okay, so recall that a reference can reference the address of a variable. And I'm not gonna just assume that you all know, so I will just create a reference here. And then we say that we want the address of num, right? So we get the address of num, we come to the diagram. We'll go ahead and copy this code. We're still not dealing with dynamic memory. And then we have this code. Some number x, some number right, some large number, and num we know gets an address, and let's go ahead and assign it to some value here, right? So the number 5 would be here, and when the second statement executes, it just simply references the number. And from previous examples, we found out that a reference does not get its own address. It's just simply kind of like a clone, right? I'm pretty sure behind the scenes something is happening, right? But on the stack, at least from what we've learned, a reference will just point to a variable. Maybe instead I'll just say reference here, and then I'll create a new diagram for pointers, just to make sure that it's very clear. A pointer so an integer pointer to an integer, we name it pointer, is equal, and we have to use the address operator to the address of num1. So we are assigning the address of num1 to the pointer. And we come here and we'll go ahead and diagram this one. So no dynamic memory. The first statement executes. 10 in binary is stored in a 4-byte address. And the next address would be 4. And when the next statement executes, the pointer gets an address. And what does it store here? It stores the address of num1. So it points to x8. And a diagram, that's the difference between a reference and a pointer. Any questions here? Yeah, so that's the references diagram, and the second one's the pointer diagram. So pointers work with addresses. So anytime we do not assign an address to a pointer, then we get a syntax error. Why? Because here we're saying give me the value of num1, which is 10. So if we want to assign something to a pointer, it has to be an address, meaning we always work with addresses all the time, 100% of the time. We can't work with values on the initialization piece, right? So this part right here is, well, maybe I'll just break it down into two. No, we'll do it. So the first part is declare pointer, and then after the equal sign, initialize the pointer with address of num1. That's the same thing that's happening over here, right? We have to declare a reference and then we assign an address to the reference. Any other questions? Make sure I don't skip anything. It's very important that you understand this concept that I just diagrammed, because if you don't, then the last 4 weeks are going to be a blur. Like, you know, if you had a hard time with objects and classes and you understood 60 to 70%, that's okay. Like, wherever you go work or wherever you are, nobody's going to lock you up in a closet and ask you to program from your brain. Okay, so if you understood the concepts more or less and you're struggling with syntax, then you can catch up. And here the same thing. Like, if you have questions right now, then ask them, because if I lose you today or in the next lecture, then that's it. Like, it's gonna be hard for you to get through data structures. So okay, so that was pointers and the address operator. What is the address operator? Is this the ampersand? That's the address operator. Why do we use the address operator? Well, because pointers work with addresses. And and that's that, right? So one thing that we have to be very mindful with pointers, and I'm sure from the class assignments, you know now that if you want to work with the address of a pointer, then you simply do this. Most of the time, we want to work with the value the pointer points to. In this case, I'll just display. So if we say cout pointer, what's this, 9? I don't think let me see. Yeah, module 9. I'll go ahead and open the test case too. Okay, and then come here and click configure all projects, and then that'll make our module 9 available for running and building and all that good stuff. Okay, so we come here, examples on module 9, and we'll go ahead and run this. So if I go back to the example, which was this is a warning that I declared a variable and I'm not using it, but that's okay. This statement outputs the address of the pointer. This address is which address? The pointer's address or the address the pointer points to? What do y'all think? num1's address, right? So then we will specify that here. We'll say address of num1. And we'll go ahead and output value of num1 we dereference the pointer asterisk, and that should display the value the pointer points to, meaning the value of num1. Value 10 pointer. So we're saying pointer points to address x8 hypothetically. The value at that address is the number 10, so our diagram does make sense. The last one, address of the pointer and we run it. So address of num1 ff04, address of pointer ff0, we have 8 and 4, right? So it's the same thing, right? So, but point being is the pointer gets its own address and it stores the address of the variable it's pointing to. Questions here? Okay, good. So no questions. Okay, chapter 10 talks about pointers and arrays. That'll be in the next lecture. Pointer arithmetic, that's in the next lecture. Initializing pointers, we've just discussed, right? Like, what are they talking about? Meaning, like, we give an address to a pointer we declare. Okay, so now we go to comparing pointers. Yeah, so when we have pointers, we have to be very careful, and it boils down to this character. With pointers, we always want to work with values, so you have to dereference the pointer, use the asterisk, and it'll give you the value. If you don't, you're looking at an address. So if we say if pointer, we create pointer 2, right? So pointer 1 equals to the address that this pointer lives in. And if we say if pointer greater than pointer 1, then do something. It's important to understand that here we are comparing addresses. Okay, why? Because if we don't specify the dereference operator here, then we know we get the address and we showed it here, right? So we don't want that. Usually with pointers, like, we always want to work with values. So in this case, we'll say this to make sure that we are comparing the values the pointers are pointing to and not the address that they're pointing to, because as you saw, it doesn't give us any error. So when we run a program it'll probably give us inconsistent results, right? Like at times, like whatever we want to do here will be okay, and then other times we won't, and then that can be a real like issue to resolve, right? Especially if we're just zoomed in and we just forget about this guy. So please remember, pointers, we usually want to work with values, we dereference the pointer. Okay, so then if that's the case, then we are comparing values. So that statement compares values. The previous statement compared addresses, and it's important to understand that. So questions there? No, that was it for polymorphism. Yeah, from now on it's memory management. Yeah, I think that was. I mean, we probably need more practice, but I mean, there's only so much time to cover each concept, right? So I think the homework was good practice. That last homework is probably the most difficult homework, right? Because it's inheritance and virtual functions, polymorphism. So, but it's good practice, and it's only what you have 10 assignments, 20%. That was only like 1 or 2% of your grade. So if you bombed it, then it's okay. Just don't bomb it on the exam. Okay, so next topic is pointers as function parameters. So in let me go to that section. So pointers became very predominant in the C language. So C++ provides support, backward support, meaning like programs that were built back then. Well, C++ doesn't want to lose those customers, so then they support functionality that was supported back then. And one of those was using pointers as parameters. So we recall that we worked with reference parameters, and we still work with reference parameters. So here we need to create a function with reference and a pointer parameter. So we'll say void ref param. We'll say reference to an integer and 1, pointer to an integer and 2. And that was the header file. So we go to the implementation file or the CPP file. And we say n1 equals 100. Dereference n2 equals 200. Why this? Because it's a pointer. Okay, so that's why we have to do this. Okay, and we go ahead and let's create a test case for this one. Ref pointers. I don't know what types was there. Test case. Reference and pointer function parameters. We have integer n1 equals 5 and 2 equals 10. We call the ref param function n1, and we have to use the address operator. Okay, address operator for the second parameter because it's a pointer. So we're sending the address of variable n2 to the pointer parameter. We have to do that. We say require that n1 equal to something and require n2 equal to something. So what should we put here? This is the function code, and this is our test case. So I'll wait for someone to take a stab at it. So 100 and 200, according to Tabitha. Any one of you agree or disagree with her? Only? Okay, so 2. So Julia and Tabitha. Okay, so this one should be 100 and this one 200. And let's go ahead and execute our test case. We run it. And it's building. Yes, so Julia brings up an interesting question, but I'll get to it after the test case. So the test cases pass. Let's get some more detail. Up arrow space dash s. So n2, so 200 is equal to 200, and then 100, I saw it, where are you? Right here. So n1, 100 equals to 100, okay? So she's saying that must have an asterisk. And my question is, are you referring to the test case or to the implementation? The test case? So the test case is just a regular variable. It's not a pointer. You see, integer. So integer n1, integer n2. So neither n1 or n2 are pointers. So we just refer to them as we always refer to variables. Now, the parameter for refparam is a pointer to some number. And we are following the rules. We're saying, oh, okay, so point to this number. Okay, so refers, yeah. So Tabitha states that the function refers to it as a pointer because it's being passed as an address. Yeah. So and the key is there. Pass me an address. That's what this parameter means. This parameter means pass me an address. And we're like, okay, I'm going to send you n1, figure out how to get the address. The reference knows how to get the address. The pointer's like, pass me an address, and we're like, okay, I'm going to use the address operator to send you the address of n2. And notice in here, I am using the asterisk because this is a pointer. Okay, so what we will do is diagram this to make sure that we understand that n1 and n2 are simple stack variables, and these parameters, we'll see how they handle the parameters when the function is executing. Okay, so I'm going to come here. Actually, let me copy this code like that. And fixed it for me. So we have this code. And let's go ahead and so stack, let's say 0, 0, 6, 2, right? Like some x 2. Okay, so n1 equals 5 right here, number 5. n2 equals 10, 10, and we won't worry about this ones, okay? We just want to worry about the function executing. So when the function executes, n1 points to, get a different color, to that one, right? And so they're referencing the addresses of n1 and n2, okay? So any questions here? That's why when we execute the function and we say n1 equals 100, n2 equals 200, the values change. So this one is 100. It has nothing to do with that 0, 0, okay? This one, 200, because we are passing in the addresses of the variables that exist in the test case, or in main, or in any part of our program, right? But I think that should make it clear. So any questions here? Okay, I'll just try. So any other questions while Tabitha is thinking how to ask her question? If you pass by reference, you don't have to change the variable when using the function. Well, both times a reference is passed. Okay, so that's important to understand. So let's go to the test case. When we pass n1 to the first parameter, C++ knows that it's a reference. See right here? Like even when we assign the address of a variable, the fact that it's a reference, we just give it the variable name. C++ understands, oh, okay, you want me to get the address of this number, this non-variable, and it saves it. That's the same thing for here. Like we say n1 equals 5, and then we pass it in, and what's happening is it's saying, oh, okay, you want me to get the address, save it into n1. So that's why we don't have to specify the address operator. With pointers, we do have to specify the ampersand, because if we don't, then C++ thinks we want to work with the value, right? I think maybe the confusion spawns from a pointer, right? I think the confusion is coming from here. So it's important, these are not pointers. Yeah, these are not pointers. Right, so, and like over here, you see, so this is not a pointer. If we want a pointer to point to it, we have to use the address operator. If we are using a pointer, then if we want to work with values, we use this guy, and if we don't, then we remove it. Then it's working with the address. So I think that's what, I'm pretty sure that's where the confusion was, right? So these are not pointers. This is a pointer. So if we go back at and look at the diagram, then it should make sense now. Why do these parameter addresses, lines point to these addresses? Because a reference means point to the original location. And since pointers and references are the same, the pointer is the same thing. It's like, oh, point to the original location of N2. Okay. So maybe we write another test case. And remember, test cases cannot have the same name, so you say pointer. So we'll say pointer to N2. And then we can say pointer. And then we can execute it. Okay, I don't know why sometimes it does that. Run in terminal. Linking. Okay, so let's see. So we know green is good. Yes. So parameters use a pointer. It passed. So what happened here? I'm hoping that now you understand, right? Because I think that the confusion was, well, why do we have to use an ampersand here? Is something, well, something will have to be an address, right? If Adrian, if you wanted to do require ampersand n1 equals to something, then yeah, it would have to be an address. But usually we're not concerned with addresses. We're more concerned with values, right? So I think the confusion that Julia and Tabitha had was, why do we have to use the ampersand? And the answer is, well, because these two variables are not pointers. That's why. And if we don't want to use the address operator, we can always just show, well, look, see, if you create a pointer that points to a number, in this case n2, we can pass it in as a parameter without the ampersand. And then that, it still works, right? And maybe we should diagram this one too, to make sure that we understand how that looks in memory. So we come here, copy, references and pointers use a pointer as a parameter. Okay, so we got that, and we have this, and we will go ahead and diagram this one. Okay, we have some address, n1 equals 5. 5. In binary, of course, okay. n2, 10. 4-byte binary number. Pointer equals n2. N2 is x4, meaning it's pointing to that address. And now we say call the function ref param with n1 as a parameter. Okay, and then we're like, okay, send pointer as a parameter. Okay, points to the pointer, right? So then when it's in the function's like, oh, you are pointing to x4, right? And the pointer's like, yeah, okay, give me the value for x4, 10. Okay, change that one to 200. By that time, this one was changed to 100, and that's how that works. So questions here? So very important that you understand this sequence right here for the pointer, like this one, like how pointer has its own address, and the address it stores is the number, the variable it points to. And that's the same thing that's happening in this example, but now we have more variables and we have a function call. Would you mind going back to the first diagram you did before? So this one. Yes, so the difference is that in this one we are just using stack variables, n1 and 2. And the pointer, we are using a stack variable, but that pointer is pointing to another stack variable, okay? So n1, this one, n2, this one. We go back here. Before any function calls are made, we have to allocate 3 addresses. 8, 4, and 0. So that will have value 5, 10. This one will store the value, the address of x4. And then we pass them in as parameters. N1 still points to 8. The pointer implicitly still points to N2, but through a pointer, right? So it comes here, and then C++ starts dereferencing. It's kind of like, oh, okay, I need to go to address x4. Okay, let me go to address x4. 10, I will change you now to 200. And that's how that piece works. Again, I know it may be confusing, but this is very important because once we get through arrays and we come into dynamic memory, then we're going to have pointers pointing to heap memory for dynamic arrays. So it's very important that you understand these concepts that we're covering today. Okay, so let's go and look at the test case. Any questions with this test case or this test case? And if you want me to explain it again, then I will explain it again. Also, while I'm waiting, like once you dereference a pointer, like in here, you can treat it as a variable. You can multiply, divide, anything you can do at a value, you can do, because you will be dereferencing it, meaning you're working with a value. So you can add to it, multiply it, divide it, any mathematical operation you can do because it's a value, right? As long as you can do it to a regular variable that's an integer, then you can do it to a pointer that points to an integer. So I want to make sure that that is very clear. They call this guy the indirection operator. Go figure. I never understood why, but that's what they call it. Okay, let me make sure that we're okay. So if there's no questions, then we go on to question. We go on to pointers and constants. So again, a constant is a read-only variable. Okay, so let's see how pointers work in that context. So the examples in the book use arrays, but we're not working with arrays yet, so I'll simplify it and we will not work with arrays. We'll just simply work with simple numbers. We have a number, we have num1, num2, so num2 equals 6. Actually, I named this size and I make it constant, right? So that is a constant number, and we can create a pointer to size equals the address of size. Let me see here. Oh, I have to make the pointer const, right? So or do I? Yep. So now we're saying const integer size equals 6, meaning size is read-only. It cannot be modified. We cannot modify it. Why? Because we just said, like, make this constant, like, meaning make it read-only. So we create a const pointer to int that points to size, and then we will see if I should have used usinc out, so I have to be doing all this typing. Value of size and we can execute it, run it. So no big deal there, right? So then I think a student yesterday was asking me, well, what if we want to have a constant pointer point to a regular number, like num or num1? Can we do that? And so we say pointer size. So notice we want to reassign the address, so we don't use that indirection operator, or we do not dereference the pointer. And then we say, okay, let's point to the address of num1. And the first thing we'll try is, well, we didn't get any syntax errors there. So then let's say, well, let's see if we can let me display the value of num1. And here we are working with a value, okay? So now we're saying point, display the value of num1, which you should be pointing to now. Right, so that's okay, and then we can try to modify the value, and now it's saying that we must have a modifiable L value. We'll talk about that in a couple of weeks, what an L value means and an R value, meaning the address, the variable must be modifiable, and it's not, because we said here, like, this is a pointer, a constant pointer, meaning like whatever we point to, we're going to point to in a read-only mode. We will not be able to modify, even though here we can point to a number that's not const, but the fact that the pointer's const, we can't modify it. So meaning that statement is incorrect. I mean, we can't do that, so then we skip it, right? I mean, we can't do anything there. Okay, so that's what it talks about, non-constants. Okay, so that was what we saw here, line 24, and this is straight from the book. If you all have the book, 668. A pointer to const points to a constant item. The data the pointer points to cannot change, but the pointer itself can change. And we saw that, right? So we said point to size, and we did. And then we say, well, can we point to another one? And it's like, well, yeah, we can. It let us. And we ran the program, and we have proof here. And the fact that our program ran and we got the expected values, then we know we can reassign a constant pointer. No, actually a pointer to const, right? So it's a pointer to const. So then there is pointer to const, and that wording, right? And then we have a const pointer so recall that references, once we assign them, then that's it. We're stuck. You know, we can't reassign the reference. I mean, unless we recompile and deploy a new app with that reference pointing to some other variable. Okay, so we have what, lost track of nums here. Num1, let's use num2, 20. And then we say, let's have a pointer, but then instead of having const at the beginning, we have const here. And then we say I guess we'll say const pointer. Const pointer equals to the address at num2. So what are we trying to show here? Well, we're trying to show that if we use a const pointer, we can assign it to an address, but then that's it. We won't be able to assign it to a different address. But first, let's go ahead and value of num2, get practice, right, with that indirection operator. So const pointer. And we execute this. So it works. I mean, num2 is 20. We point to num2. We display the value via the pointer. But now, let's go ahead and try to say that const pointer will point to another number, like num1, and it doesn't let us. So now we made the pointer read-only, meaning we can't change it. So now it works like a reference, right, in that aspect where we assign it an address and we can't reassign it. So questions here? In this case, we will be able to change the value of num2. Yeah, so we'll get there. Makes the pointer read-only. Okay, so let's go there, right? So we displayed the value of num2, and then we'll say, okay, I don't want to work with addresses. I want to work with the value. So let me change this to 25. So what do you all think? Will it let us change or not let us change? From what we see here in this statement right here. Okay, so we have 1 for no, it won't let us change it, and then should not, I don't think it will let you. So 3. Okay, so then we're like, well, okay, well, let's check it out. So value of num2, and we run it. So we're looking at this output statements down here, so 20 and 25, right? So how does a reference work? Is the first question. So a reference can point to an address, it can read and write the address, but we cannot assign it to a different address. So a const pointer is referring to itself, like I am const, meaning I can only point to one address, and once I point to an address, I cannot be reassigned, but the address which I point to is read-write. I can read it, we read it here, and I can write it, we wrote it here, and then we display it just to show that, yeah, I mean, so that's also important to understand. So questions here? Yeah, so we look at the definition, right? So the first type of pointer, this one, pointer to const. So a pointer to const points to a constant item. The data the pointer points to cannot change, but the pointer can change, and we proved that, right? So I did show you, right, where I was trying to change the value. It doesn't let us, like here. Pointer size doesn't let us. It's saying that it must be a modifiable L value. But we tried to reassign it to point to a different variable, and we were able to. See, size is 6, num is 10. Size is 6, num1 is 10. Here, what we're saying is the pointer itself is const. Once it's assigned an address, it cannot be assigned a different address. But the variable it points to is read-write. And we showed that right here. Go back here. And I think here. Yeah, so I'm going to skip the next piece. It's const pointer to const, meaning where the pointer cannot be reassigned and the value it points to is read-only. So that one is a constant pointer to constant, which makes sense, right? Like the pointer is const and the value it points to is const, so it cannot change that value. So if you want to look at that example, it's on page 669 in the book, but we won't cover that. Okay, dynamic memory, we skip it. Section 10.9, we will get to it next week. Dangling pointers, get to it next week. Returning pointers from functions, we will get to that next week also, because we have to deal with arrays and we have to deal with dynamic memory, and we've not talked about either, so I can't cover that example. Memory leaks, we'll talk about next week. Pointers to class objects and structures. So, okay. I think I'll close all of these guys, close all. Module 6. Main. No, actually I didn't want to. I wanted to go to the shapes example. Main. No, that's a library. Where am I? Okay, I'm here. This is what I want. Okay, so we have the shape example, right, where we have a circle, line, and we'll work with a circle. So if we create a circle, so we create an instance of circle, okay? Oh, circle already exists, but let me, well, maybe I name it something else, right? Circle 0. So it can leave us alone, okay. We create circle 0, and now we want to create a pointer that points to an object. Circle is an object, so let's create a pointer, right? So we can say, okay, I want a pointer to circle. So then this is a pointer to circle. So usually when we declare a pointer, we want to initialize it to some value, but we can't always do that. Like when we're programming, like for example in the tic-tac-toe application, you create a pointer to tic-tac-toe, unique pointer to tic-tac-toe, but you don't know which instance you will create, not until the user tells you, right? If it's 3 or 4. So then you declare the pointer and you leave it there and then prompt them. But that's generally not safe. What we want to do is we want to initialize a pointer to 0, which is the legacy way. Or we want to point it to null, which is still the legacy way. Or we want to do it the C++11 way, null pointer. All of those behind the scenes point to 0. And when C++ sees that a pointer points to 0, it means, oh, it's pointing to nothing, right? Like that nothing. C++ knows, like it points to address 0, which is nothing. And if we try to use the pointer, then we won't cause any harm, right? But if for some chance we say circle, pointer, circle, and then we execute it, then it might be that the address, assuming this was the circle address, by some chance, there was an object circle here before, so now we are pointing to a circle that's obsolete now, and then our program test cases pass or whatever, right? Or gives inconsistent results, and we're kind of like, oh, what's going on here? So we can avoid all that by simply saying, okay, I'm just going to initialize it to 0, meaning like whatever address you give me, that address is going to point to nothing for now. So then once we do that, we're like, okay, so pointer circle. So pointer circle equals the address of circle 0. And now the pointer points to an object that lives, right? That is in existence. And we can say what? Well, recall that if we have a pointer to something and we want to access the functions, we can use the arrow operator, and notice that it knows. So what is happening here? So it is dereferencing the pointer we're using behind the scenes for us, right? But this is cleaner syntax, and the book goes, and I don't understand. The book's like, well, I mean, you can do this, right? It's kind of like, okay, you can do pointer circle draw. So which one syntax would you rather work with? That syntax or this syntax? Ever since I was in grad school, I was like, well, the second syntax, because it's, I mean, C++'s syntax is already confusing. So anything I can do to avoid any confusion, that's the route I'm taking. And actually, well, you'll be glad to know that this is a recommended C++ way of working with a pointer object and accessing its functions, right? So you don't have to go through all that hoopla. So questions here? And then, well, one question should be, well, I mean, will this program execute? All right, so okay, just to keep track of what's going on. Okay. Okay, so that should work now, right? So we have IOStream here. We don't have any using C out. That's why this was not letting me compile. We come here and run it. And we make this larger. So draw circle, first circle example length, so meaning our example works, right? So we create a pointer that points to a null pointer. We create a circle object. We have our pointer circle point to the circle object. We use the arrow operator to dereference the pointer and access the class draw function, which we do, draw circle, and then the program continues. So that's how you point a pointer to an instance of a class or an object. I think that's enough for today. I know we covered a lot, but this is the building block for the rest of the semester. So please make sure that if you had issues or questions or concerns, and go back and watch the video, go through the examples to make sure you understand how pointers work, because we're going to use pointers from now till the end of the semester. Make sure we do the memory management issues. How early do you think you have the video for this lecture? I'll post it tonight. So let me stop the recording.